If we use the conditional expectation to predict y based on x, then how much error do we make? That's a question we have to be able to answer. Every time you produce a prediction, you should have some kind of sense of the plus minus number. So just to recap, we have a random point xy. You see x but not y, and you have to predict y. Based on previous calculations, we've decided to use the expected value of y given x as our predictor, and that's what we've been calling b of x, for best predictor of x. We showed that it is the least squares predictor, and the amount by which we are off is the vertical distance y minus our predictor, and that is what we were calling the deviation within the vertical strip. And what we would like to do now is simply to define the conditional variance of y given x. And you will recall that every time you see given x, we are restricting the possible points to this vertical strip at capital X. So we now want the variance of the points that are restricted to that strip. So a natural notation is the variance of y given capital X. Let's just see if we can come up with a definition. You have enough experience now. You should understand how quantities are defined. First, it is something conditional given x, so in the end the answer is going to be something given x. It's going to be the expectation of something or other given x. Okay, the expectation of what? What is the variance? The variance is the expected squared deviation. So there is going to be a squared deviation somewhere. The deviation of what? Well, there's y, and you have to subtract off its mean. So what is the mean of y? You are maybe tempted to say the expectation of y, but remember that we are only allowed to operate within that vertical strip. So the mean of y then is the center of that vertical strip, which is not e of y, but e of y given x. And now for the variance, you want to square that. And so you want to take the expected squared error where all of the action is happening within the strip. And that's a lot of parentheses. So let's recall that we have a notation for y minus this conditional expectation. And that is d of w. So we have the expectation of this vertical error squared given x. And that is the definition of conditional variance. For interpretation, if you use bx, that is the conditional expectation, as your predictor, you'll be off by not a variance, you'll be off by an SD, a conditional SD. And I'm going to loosely say around, and you know that means that you will be correct to within, a small number of multiples of the conditional standard deviation. So at the end of all this, what we have is a definition of conditional variance. Next, we are going to use it to calculate unconditional variance.